Okay, we are live. Wow, very nice. Looks like everything's working. Okay, time to get programming. Let me open up the Arduino PLC IDE. Okay. Open project. Which basically means I do whatever I want. Okay, so here we are in our IDE. How do we get going? I gotta catch up. I haven't done this program. So this is a project I'm working on, trying to start a business selling coasters. I know, kind of crazy. And I have a manufacturing line in my garage, and this PLC is going to control a hydraulic and two air cylinders, which is on a spool valve, and let's see what else. A shaker motor, and that's about it. I don't have any safety set up right now. Who needs safety? It's just like, safety's so much work and doesn't really do anything useful for me because, I got all my digits still. So until I lose one of these, I think I'll be fine, you know. So that's what the project is. But I had this program started like, oh gosh, like 6 months ago now. And it's like been really like a long project, way longer than I thought it'd be, because manufacturing or making manufacturing equipment is difficult. So I got to go back and try to find out what I did and what I need to do, and so I'm going to be like kind of digging around here. And this is a part of the project I'm not really super excited for. It seems like it takes way more time to do all this stuff than I would like. But, I'm live and we're going to be trying to work on this together. I'm just going to be chilling here, working on figuring this out. And once I get this done, my machine's basically ready to run. And so I'll have some good production soon, which I am very excited for. Like, it's palpable how excited I am. I wish I had camera. Is this camera best? Yeah, this camera's probably best for this view. I also have another camera over here, but my chat's all the way over here, so we'll see how this works out. I mean, I'm new to streaming. I'm not very good at it, but I'm just going to work on it as I go and, keep a cool head, keep the chills, keep the vibe chill, and, we'll figure this stuff out as we go. Okay, without any more rambling, I'm going to try to start work. So you have two parts here. Yeah, this is what I remember. You have two parts. You have the project and the resources. So let's take a look at our function here. I really do not like this coding structure for the Opta. I'm really not actually that big a fan of the Opta. I feel like the Opta is a pretty bad product. It's not really a PLC. I know I put PLC in the title, but it's hardly a PLC. It's more like a programmable logic controller. Okay. Bum 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 bum. So if I remember correctly, we had a couple variables here. So yes, we have our LED variables here set up already. We have some relay outputs. Do we have inputs? I don't have these declared. I have these declared. I don't have any relays declared. The buttons mapped. So first thing we have to do is figure out what we want to get done today. And so the goal is to have the the PLC running. I mean, that should be pretty easy. I had it running a couple weeks ago. I need to have it the button box. Let me grab it. Oops, geez, everything's a mess. Everything's a mess right now. So let's see. So button box, which is here. This needs to have, I want this button, this red button, to be mapped to the my shaker motor. I need this green button mapped to my spool valve here, which I have, but I need to figure out the controls on. And then I need the e-stop I have. So here's my board. Let me show this off. Can you see that there? So I have a relay, wherever I can find it. So I have a relay that's already mapped to my e-stop. So that's all electronic. I like having my e-stop on a 24-volt separate circuit. I don't really like the safety controllers. I know that Keyence and what's the other big one? The other one we used. Well, I mostly use Keyence software in my job. And I know that Keyence has the controllers. They're great products. I think they're really overpriced. A relay, for my application, it's a small time, will be fine for a safety circuit. And so I have the safety circuit wired up so that it'll cut all the 24 volts. So all my yellow wires here, I don't know if you can see any of them. Where is my camera? So all of my yellow wires are on my safety circuit. So it'll cut power to pretty much everything except for the logic controller and the 24 volt power supply, which are on mains. And so I don't really have to worry about that on the programming side. I do want a one of the inputs to read it, and I have an input wired up right now to read my. I got a couple inputs on my safety circuit, so I'll be able to read it and know that my machine's e-stopped. And then I want to wire up, so 2 buttons and this switch. I'm not wiring up my hydraulic cylinder today because that seems like way more hassle, and I haven't completely figured out the wiring on that. And so we'll probably, once we get this running, we'll come back to it a bit later and get that hydraulic cylinder, which is not right now when it's in the garage, but we'll get that wired up a bit later. Okay, so let's make a little list here. I don't have nearly enough desk space to be doing this, but that's okay for now. So make a little list. Let's see. First one, we want to map the I/O. 2, we're going to make a little logic circuit. We'll just map or we'll do just make a logic process. So let's see, and is there anything else we need to get done today? I think that should do it. I don't really want to set up a fully automated cycle today. I think if I can get just the button box working, that it'll be pretty successful, and we can revisit it. Eventually, I want my machine. I have a manufacturing machine. I want it completely autonomous, but that's probably a little ways away because that's a lot of work to get it there. So we'll just see how this goes. So yeah, let me get it all plugged in, and we'll see. I don't know if I mentioned this, but I'm not a huge fan of the Opta. Arduino's trying to get into industrial electronics, from what I can tell, but it seems like they're going about it kind of backwards. Like, they have a great platform in the Arduino lineup, and then they're trying to do all of this PLC work and trying to back themselves into it. And I feel like if they kind of stuck closer with their roots in their field, it would have been a lot better implementation. Because working with so far, this Opta has not been super enjoyable. It's a newer product, so maybe that's part of it. And as they get more years into the development cycle and they have more supporting equipment and documentation and everything, it'll be better. But I mean, so far, I feel like this controller is a little bit underwhelming and a little bit archaic somehow, because you'd think Arduino would make a product that's, futuristic, but it feels like I'm going backwards in time compared to like my Alan Bradley experience. But well, it'll be a fun project still. We'll get this going. There's no reason we can't do a simple project like this on the Opta. Okay, so let's get it connected here. If I remember correctly, it's this button. Let's see. We are connected. I don't know if you can't see that because my face cam is there. So we're connected. It says it's not running, which is what we'd expect. Let me press a button to see if it's working. Okay, perfect. So we have power to it and everything is working. Let's see. Let me move my face cam just up a little bit. So there. So now you should be able to see the process. Okay. So let's now take a look at our I/O. So LEDs, the Opta has these 7 built-in LEDs. Right now I just have them mapped to different variables which I can control. Eventually I'm going to have, I want each of my actuators, so that'd be my 2 cylinders which are on my spool valve, and my shaker motor to be triggering these LEDs. It's not, I mean, you'll know when these things are active, but it's nice to have a little readout on the PLC so you can see that the code is running properly before you wire everything up on the floor. So that's looking good. This user button that we have on the Arduino PLC, this is the built-in button on it. I don't really think I'm going to use this for anything. This is maybe, I might end up programming this as a reset button to reset all my variables to an initial condition. Relay output. So this is what I have. So I'm going to have to check my wiring to make sure I get these relays. Sorry about that. Get these relays wired up correctly. Because I have, right now, let me move this a bit closer. See, right now I have, it looks like 4 of my connections. So I'm going to have to, let me figure out real quick. I'm going to have to multimeter this out and see what my wiring is. Because this is the hardest part about doing wiring, is remembering what you did a couple months ago. So I have my, oh wait, can I even see this? Okay, so I have my 2 buttons here. So I have, where's my cam? Oh, I'm on this cam. Okay, so I have my 2 buttons. I got my, only have one of them wired right now, and I have my switch. So I'm just going to do my switch and my button right now. And that is, let's see if I can continuity test this real quick. You gotta love wiring. Okay, so that is wired to, let me see my switch. My switch is wired to my expansion module. So I have the expansion module on here too. So I have that on the, let's see, what is that labeled? 12. I have that on input 12 of my expansion module. And I think that's here. So we'll label this as switch. And then I have my button. I have it on input 11. Okay. Input 11. And let's see, do I have anything else I need right now? Let me put my relays in as well. So I have my spool valve here, and this is on just a simple 3-leg, if I remember correctly. That it should be just a 24 volt off of one of my relays, but let me open this up just to make sure. Yeah, I think that's, yeah, here's the labels. So it just, one of these is ground. I think I ran out of green wire when I was doing this, and so I never labeled my ground. But if I go back, I should probably rewire this and use proper color coding. But, you know, that's whatever. It won't stop us today. Okay, let me probe this now. Where's... Okay. So my spool valve is not, let me see, I'm not getting anything off of this. So it looks like it's not connected to my relay. I gotta find it now. It's always something. Let's see where this goes. So there's my ground. So I did do a little bit of heat shrink so I can tell that that's my ground. Where does my power come from? I lost my power wire. What? What am I doing here? I don't know where this power wire goes. Why is this? Maybe I have an open circuit in here because one of my wires broke or something. Oh, well, maybe that's it. Okay, so this should be 24 volt negative then. This should go to here. Okay. Okay, I found it. No, it's all working. Just somehow the multimeter wasn't catching it. Okay. Always gotta love the floor screws. That's my favorite part about doing anything in life. So it was on relay 4. So the way I have this hooked up is I have 24 volt. It's a 24 volt valve. So I just have 24 volts on the one pin. It goes to ground. I have a ground terminal block. Here, I'll try to show it. It's just, this thing's unruly. I wish I had a top-down camera right now. Okay, so, let me see. Oh, I'm still plugged in. Let me just unplug it for this. So, okay, so I have a 24 volt power supply here, and that's running to my main 24 volt negative power supply. Well, here, let me go. Can we go here? Perfect. So 24 volt power supply here runs to my negative 24 volt and my positive 24 volt. Well, sorry, this is positive 24 volt, and this is positive 24 volt on the safety circuit. So this is my safety relay that's hooked up to my e-stop, and let's see. And so what was going on is that my spool was connected to relay 4 right there, and then the negative connected to my negative 24 volt. Okay, so now we have all that mapped out. Plug it back in. Okay. So that is on relay 4. So now we can go to our main board here. Relay output. Relay 4 is our spool valve. Okay. What else do we have? I have a shaker motor. So the application this is being used in is I'm using it to stamp out coasters. I know it sounds a bit weird, but yeah, I have a business making coasters and a stamping line. And so I have a shaker motor to shake the sediment and to shake the material. And so I have a motor that does that, and then I'm going to put that on one of these relays. And now I got to find out where I have that wired up. I have a pigtail here. And I think that's what I have, this pigtail that I was planning to use. I think I have this on the relays. Let me see. But I don't really want to use this because this wire is fine for 24 volts, but I don't really feel good about putting mains through this. That would be a bit of a bad idea. So let me see. Is this just ground voltage? What do I have on this side? Why do I have this all? I have this all at 24 volts. Was I going to use another relay? I don't have a reason to use another relay. Right now, I'll say I'm going to put my shaker on relay 3, but I'm going to have to rewire this. Because I think this was, I don't know why I have 24 volt on that relay. Or I could use, actually I'm just going to put it on my expansion module. I'm going to put it on my expansion module because I have relay outputs on there. And we'll keep all the wiring as is. That way I have room for expansion. Or I can use the 24 volt pigtail that I made myself without changing anything. So we're going to put it on the expansion module. I'll just put it on 1. And this was my shaker. And so that'll be 120 volt mains. Let me think. What else do I have? So the way the cycle works is I have a hydraulic press that comes down. It'll press. Well, I have probably a. Look at the fusion. Take a look at the CAD real quick. Gotta love fusion. No, I need to sign in again. Okay, well maybe we won't look at CAD. I have a drawing packet. Let me pull up the drawing packet. Let me sign in. I gotta sign into my email here. Do I have it in here? Sent mail. Here's my drawing packet. Okay, perfect. So I have this press assembly here with this is a hydraulic press, and it presses this upper plate down. I have this is a mold plate which shapes my product, and then I have a lower plate. And so basically what happens is I have this hydraulic press. It pushes the material down, squeezes it in between some upper molds and this mold plate and this lower mold. And then I have this hydraulic press. It'll open up a little bit, so it'll go up just a little bit. And then I'll use these hydraulic air valves here to press up the material. And then it will give enough, press it up enough so the coasters will fall out of the mold, and then I can take them out, and eventually they'll be pressed or pushed out of the mold with this other air cylinder here. Right now I only have this main press assembly built. I'm going to build out the rest of the line once I have this proved out and running. And then this is my control cabinet where my electronic panel, where my panel will end up. Here you can kind of see a side profile. So this top piece goes down, then I need this bottom piece to go. Well, I need the top to come up a little bit, then the bottom comes up a little bit. And then I will, right now, manually remove the product. But in the long term, this cylinder will then extend and push the product out of the press contraption, and then the cycle repeats. So we have, right now though, we have this hydraulic cylinder attached to a different button box. So that is running independently. I don't want to make that automated because this is like a safety concern, so I don't really want to automate that main press action until I have the light curtain and everything set up. But I still have to acquire that. So for right now, this will be done on a manual up-down button box, and then I have the rest of it running automatically. So when I press it down, I'm going to have the shaker motor turn on, and right now I'm just going to turn it on with a switch here. Eventually it'll have a little prox sensor that'll turn it on, and then I want to give it some time, and then I'm going to then use, right now I'm just going to use this cylinder to trigger the spool valve, but eventually that will be running off of a timer or some other control logic. Okay, so we have shaker. So right now this should be good. So now we can go to programming. And I am not a fan of programming the Opta. Like, it seems like they made this as unforgiving and unenjoyable as possible. They have some like accommodations. Like they have ladder logic and flow diagrams. Um, that might be the easiest way to do it today. They also have structured text, but the structured text is not implemented very well because when you have the expansion module, they don't really have a lot of documentation on how to use the expansion module and how to reference it, especially because they have this two cores. So their PLC, they call it a PLC. I call it a logic controller. Um, it has two cores, like an Arduino core and a PLC core. Um, and so you have to kind of cross talk between the two, and it just feels like they're fighting each other at every point. So this has not been terribly enjoyable. It's until they get this all ironed out. It's going to be a bit of a pain. But for today, let's see. We'll probably just use the structure here, and we'll just use this to control the relays. So let's just initialize our variables here. We have two variables. We'll just initialize our two relays. And our two relays are the shaker, and then we have the valve. Okay, so we have, I had this set up with a cycle. I don't think I'm not gonna keep this cycle, but I'll keep it around so I can copy and paste. So originally I had it set up so that I had this push button, and if you press the push button, it will push it forward in the cycle. So you had these, what was it, 5 states in the cycle, and every time you press the button, it would advance it, which is closer to how I'll eventually have it running. But right now, I just want it more simple, more manual, more control. So we will just do it like this. If we'll also need to declare our buttons here. So how did I name this? I have a very bad memory. It seems valve and switch. Did I double name that? That would be not good. Oh, I did. So I need to change the name here. And boom, 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 boom. What? Did I? So we have the relay. The output is the valve. And then both of our inputs is, no, button and switch. Okay, that's fine. So button. Okay. So now, well, the switch is not a button, so we'll need to switch. We'll need to change that. So if we go here, the switch will be a. Excuse me. Well, maybe it works. Huh. Well, we'll see. Let me plug it in and we'll just see. Oh, it's already plugged in, but it's not connected. I need to connect it. Come on. Unable to start communication. Let me reboot it. Just getting the PLC initialized was quite the headache because it doesn't want to. It never wanted to flash right, and you have to reboot it a bunch of times. Let's see. Where was it? Come on. Let me save this and I'll have to close out. Oh, come on. Let me just restart this. So let's see if it connects. Oh, damn it, what did I literally changed nothing and it wants me to reconfigure it. Okay, fine. We'll reconfigure it. Okay, set up communications. Should be good here. If everything's good, I don't know why it's not connecting. I'm just gonna take this and try to type it into the old Google. You gotta love problem solving. Communication. One line / setup communication to configure, but it should be already configured. Let's see, Google says this indicates that your software confirm Opta. Okay, Modbus connection usually clicking the wrong COM port. I hate COM ports. I don't want to be using the PLC communication. Am I on? I'm literally on the same COM port. Just unplugging it and I have an issue. Let's see. Well, let's try a different COM port. Properties. See, this should all be good, though. It was just running. Modbus. It was. It is. Like, Modbus protocol. I have it set up to Modbus. Step import. Identify step 1. Let me just try different ports then. We'll just try all the ports. So I changed all the ports. Let me just reset it again. And all I need is a little green box. That's all I need. But it doesn't want to configure. Properties. It's on COM port 1. Baud rate is good. Everything here is good. I have active Modbus. But it doesn't want to connect. Unable to connect. Oh, God. Still doesn't work. Put the Opta in bootloader mode. I don't want to reflash it. Set a the reset button. Oh, wait one sec. There should be another button. No, it's the user button. Gotta get a screwdriver now. Here's my. Okay, so now I put in bootloader. Still no connection. Let me try resetting it. Like, you gotta love actually doing things in life. Actually doing things is way harder than it ever should be. So you know this isn't scripted. Okay, well, we're just going to move forward with the logic, and I'll have to figure out how to flash it later. I can program without flashing it. Because it's being stupid. Okay, so we have... So first we want to start with the shaker. If shaker... So this means that if shaker is true... Sorry, if button is true. Switch. This should be on switch. We want then to make shaker true. And we will take this and we'll just copy it. If button is true, then we want the valve to be true. Now, if only we could get the dang thing to connect. So I'm just going to remove all of this logic here. And so we'll also make this so that the lights come on. So if this is true, then we'll make the first light come on, L1 come on. And if this is true, we'll make L2 come on. So now the light should come on when I press the buttons on the button box. Let me Google it. We can always go to YouTube. Different USB port. Normally this is fixed just by power cycling. This isn't the first time I've run into this. But this time it really doesn't want to just work from a power cycle. Let me see how I run it in bootloader mode. IP config, because I already tried the bootloader mode. Bum, 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 bum. Back to reading documentation. One of these days I'll have everything figured out and then it'll be beautiful. But until then, I'm stuck reading documentation. Countered with the PLC IDE. Here's the breakdown of the problem. Previously had successful. Yeah. Status. You can automate. I feel that they need to release hardware that's bug-free. I shouldn't lose all my settings just from unplugging it. That's pretty ridiculous. Okay, open the PLC IDE software and open a new program. Open the Windows Device Manager. Port numbers. Plug in the USB data cable into the Opta and then into your PC. Windows Device Manager, look at ports, note any new ports that come up. Arduino PLC, go to online setup communication, set up the communication by selecting Modbus. Opening properties, the port number, select the lowest number in the new port, step 4. Click OK, click OK. I'll have to press the reset button. Go into bootloader mode. Arduino PLC IDE, click the Resources tab and scroll down to the Other box and select Automatic Bootloader from the drop-down, then click Download. Let's try that. So we want to go to the Resources tab, which is where? In the Arduino IDE software, click the Resources tab. Oh, Resources. Scroll down to Other box and select Other. Automatic bootloader. Let's download the bootloader. Maybe it's a version issue. And all of this just to change some switches. It's amazing how hard it is to make computers do something in real life, especially when you're going for, I don't know, a cheaper option. With Allen Bradley, you would have spent $10,000, but it would already be done. And then you have to pay for an Allen Bradley key and some specialty guy to come out and take a look at it, and probably a programmer like me, and it'd be expensive. So, but I mean, in industry, having these kinds of issues where it takes a day to figure out how to get the bootloader to work, it's just cost prohibitive. You're paying a programmer, I don't know, like $200 an hour if they're on site, and probably closer to $150 an hour if they're remote. And you just can't afford to have them messing with it all day trying to figure out the bootloader. I mean, you just need the stuff to work. And that's why you have Allen Bradley is just or Siemens or whatever, and they just work. That's what Arduino needs to figure out if they want to actually break into industry. Okay, go to Setup Communications. And by selecting Modbus, well, we already did all this. It should be on. Let me unplug it and we'll see. I moved it to a different port, so let's see if that helps at all. Let's see. Let me open up Device Manager. Okay, COM port. We have COM3 and COM2. Let's plug it. Where's COM port? Computer. I guess it went away. So it's on COM port 3. Okay. COM port 5. Sorry, COM port 5 and COM port 3. Let's look at our. Oh. I might be stupid. Maybe it's just because it doesn't work on USB 2. If that's the case, that's also pretty stupid. If they can't flash it on, you can't. So apparently, you can't flash the Arduino Opta off of a USB 2.0. That's the black plugs. If your plug is black, that means you can't flash it. You have to have a blue USB port. I wish that was in the documentation. If somebody mentioned that, that would have been nice. Okay, back on track. Back on track. So let's see, we're connected. Can you see it there? Yeah, we're connected. Not running, but we can now load our program. So if we go to load our program, which I always forget how they want me to do that now, because you have to. So let's compile it, see if there's any errors. There are. Invalid access to variable. Let me see, why is that? Is there a spelling error? Oh, is it because it's on here? So it's on the. No, I'm not getting the variables off of the. Interesting. I'm not getting the variables off of the expansion module. Hmm. Bum, 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 bum. IO mapping. So let's see. Why am I not getting the... I have it for the e-stop. Am I using any of these other... Next PB. Is that how I spelled it? Everything here is cap sensitive, so you kind of have to be aware of the capitalization and everything. No, I have a cap stop. Capital S. Okay, let's compile this and see what it does. Now 3 errors. So how does it want me to declare them? Because I'm sure I have to add them to some map. To invalid access to variables. Let's see what the internet says. Hey folks. No, you cannot directly assign the return value. You define. Well, this is not an opta or what? But they're using the Arduino language. I might try writing the next version with their with the other Arduino IDE, not this PLC version. But I don't really know how well that'll work because you don't really get full control of the PLC if you do that. But I guess in most applications it probably doesn't matter, so it might just be faster to do it that way rather than messing with all this. But some of it's just configuration issues, and that's going to be the same whether you're using the PLC IDE or the normal one. Bum, 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 bum. Variable mapping assigned to the expansion specific input and output resource menu. Let's see if we can do the watch. Let's see if we can watch the variables. So we'll go here. Variable input. Can we do it here? No, we need to add it here. So I think it's insert new item. Name. Location. Bum, 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 bum. Here we are. Watch. Yes. Can't add to watch. Maybe there's a conflict and that's why it's not happy. Let's say instead of button, let's call this. This will be the valve on. Valve on symbol not found. Let's try. Location. Actually, I don't know what any of this is. I don't know what they want here. Main. But it can't add it to wash. Why though? Can we add our other inputs to the watch? Why did I even put it on the expansion module? Maybe I'll just... Let me look at user button. So let me add the user button and see if we can watch that at least. Full name. Where is user button? Oh, PLC button. Let's try it. So that works, and if we press the button now, you should see this light up. It doesn't. Okay. Do any of these buttons light up when I do that? No. Relay output valve. Oh, I don't know why this wouldn't work. Maybe I should rename the stream to Watch Guys Struggle. Let's kill this. Invalid access. Oh, huh. It's read only. So if maybe that's, well, if that's the case, that's not the best documentation. So on the internet, it says it might be because the values read only. So I have to initialize it somewhere else. So it's upset with the e-stop button and switch. Now I rename button now. And e-stop So let me remove this. And what did I call this now? I renamed this. I gotta go back and find it again. I renamed it to valve on. Let's just do that, valve on button. But we can't use this, so button, switch. So if we take that away, compile it, let's see what it says. Because if it's read only, that means I need to initialize it in the input screen. Because I want to make sure that every time I start it, that it doesn't start, the machine doesn't start randomly doing stuff, right? Because the variable's initialized in the wrong condition. So if we look at this bool, there should be like an initial condition. Where do you set the initial condition? Interesting. Let's see what this does. Let's push it to the machine and see what it does. Cannot download. Configuration not matching. What? Why would the... Existing expansion will not be modified or removed. Please manually adjust the project I/O configuration. Why is it not reading the expansion module? Oh. Ew, I forgot. That's another thing. The power... Okay, now I'm remembering. Flashback. The power... The expansion module doesn't have a power pin for whatever reason. And so you have to power it separately. So I need to get my 24 volts power supply plug in. I don't know why they didn't just add an extra pin in the expansion connector so that it just automatically gets power. Maybe they thought they wouldn't get enough power off the USB anyways. I don't know, but I wish they'd label that. Okay, well that didn't do anything. Oh, it's not plugged in. Okay, so now I actually have power in my expansion module, so maybe it'll actually read the variables now. Oh my god. Okay, scan. to scan IO lines. Please connect the target and try again. So now we lost connection because I plugged it in. So why wouldn't we? Can we reconnect? Okay, so now we're connected. So now we can scan. Configuration is good. And so now we should be able to push the code. And now we have, okay, so now it's good. So let's see now. Can we watch our variables now, maybe? Okay, so now we can actually watch the variables. So now if I press the button, it still does not see it. E-stop was on. The e-stop was on, so maybe that was impacting it. But no. Okay, so let's get the multimeter out and see if we're getting power first. We need to first confirm that we have power on the right pin, and then we can see if it's just not reading it in the software. So what is this on? We're looking at input 11, valve button. Okay, yeah, so I see that I'm getting 24 volts on that input, so that's good. So there is definitely power reaching that that input. Valve button on, valve button on. So why is it not? So why is it not reading that? I don't reference it at all on here, so there's no way it's being changed. Why don't we have it? Let's check for e-stop. I have the e-stop wired. E-stop should be here. So e-stop. Okay, well, the e-stop is triggering in reverse. Oh. What is the e-stop doing? Why does that trigger a... What? Why does that disconnect it? It doesn't cut power to the module. It's not like it reboots it. Did I just have an issue with activity? Try reconnecting, I guess. So now e-stop is true. So now if I actually e-stop it, it goes to false. I don't know what I did then. Okay. How do I set the default condition on this? That's not the one I wanted. Okay, let's see what it says. YAML. Okay, well that's definitely not the right. This is not right. Oh man, that's funny. In the variable declaration step-by-step guide, double-click the global variables, but well, we can try this. We'll just add the e-stop to the global variables, and maybe you have to add it there to then define it. Insert. Yeah, so now it won't let me add it here. So default value for input is on me. One sec. Maybe it doesn't want to let me redefine what high and low is, because I wanted to define 24 volts as low, but maybe they won't let me do that. But that's fine. So right now, even though it says it's e-stopped, it is actually e-stop is when it's high. That means it has power, which obviously means that the safety circuit is live. And when the safety circuit is live, all the relays have power. So I run all of my control logic through the safety relay. So when the safety relay goes dead, that's when it actually is e-stopped. But I guess they don't want to let me rename this as e-stop low being active. That's fine. That's fine. That's not really on them. That's not really a complaint. No, I don't know why I don't have the button though. Cause let's see. Because the e-stop works, and I'm seeing that, but I'm not seeing the button. Let me add the switch here. So these are not showing up. I want to confirm again that I have power, because I should definitely have power right now. 24 volt. 24 volts. So I definitely have power. Let's see. So you can see that that's the PLC button. That's the built-in button. And that's working properly. But these switches are not reading properly. One. What the heck? Oh. Oh, it's because I put them on the wrong. Okay, oops. That's on me. I read it wrong. It's not I11, it's just 11. So here, that's on me. So this would be then the valve on button. We'll just call it valve button. And this is switch. I just named them wrong. This is shake. We'll call it shaker switch. We'll delete these. Okay, so now we can. How do I remove them? Just remove all. But I just want to remove this one. Can I now remove one? Maybe just delete. Okay. Okay, so now we want to look at valve button. What? I said I want to look at valve button. But it doesn't show up here. Let me see, maybe I need to save it. Valve button. It's definitely a variable. But it doesn't show up on the screen. Let me try to set the address. But I don't. Why no show up? What? Maybe I need to save this. I don't know. I shouldn't need to refresh the page. I mean, something's going on here. Maybe it should be able to read it without declaring it in the code. Shaker switch. Put these. Maybe do I need to assign? Oh, one sec. Oh, come on. What is going on? Why does this move this down here? Okay, whatever. I mean, they're definitely recognized, but they're not showing up. Just save it and reload. Save the project and reload it. Connect to it. Maybe it wasn't connected. Maybe that's why I wasn't adding it. Let's look. Browse. Let's add the e-stop here. Let's add the shaker button. Or the valve button, sorry. Valve button not found. Can't add to watch. But why? And why is it only giving me that pop-up now? Assuming I'm going to get the same for the shaker switch. Okay, well, we'll go back to the old Google. Okay, let's see what it says. The debugger cannot find the variable memory address due to the compiler optimization. It was in scope. Let me reboot the Opta, I guess. I didn't really reboot it, I just reconnected it. Let's see if that helped at all. Now I'm back to the other situation where it doesn't give me a pop-up at all. Great. Oh, can't add. Let's see. Do I need to? I need to build the project. Let me try. Now maybe, maybe. What is going on? I mean, it's connected. Let me flash it. Why not? Let me flash it. Okay. Valve button. So you need to flash it. I wish they said that. This just feels like a lot of bad documentation. And the pop-up messages and the error codes are just really not well defined, and they're just not very useful at all. And so this is taking way too long. Like, and I'm sure if you know everything and you use it every day, this won't be so bad. But no one I know would be willing to take all this time to do it. They would say just it's unusable. Because you need, if I can't figure something out, it should give good pop-ups. It should give error codes that actually mean something. I feel like this was kind of this IDE was thrown together. It's like a side project, and it's not really important to them, it seems. Okay, what was the other thing we wanted to load in here? We wanted to load in the shaker switch. Okay. And now we can see that we actually have everything working. So you can see here, when I press the button, we get the shaker switch. When I press this, sorry. Oh, I have it backwards. Okay, well that's a bit of dyslexia, I guess. This needs to be switched. Now, knowing this, I probably need to reflash the board to make this work. So let me reflash it. Warm restart required. Let's reflash it. And now we should see when I press this button, the button is true, and I turn the switch is true. So let me show it just for the fun of it. One sec. Let me step away for a second. Okay, I'm back. Okay, let's see. So we have the switches working. So now we just need to do the programming. So let's see. Does that actually? No. So let's start by getting the lights on the display to work. So I'm going to program the. Let's add the I/O for the outputs on here. Do we actually get control over these lights? What status? Relay outputs. Inputs. Well, maybe we won't do that. It's fine. I don't know how to control the LEDs on the expansion modules. Okay. me see. It didn't. I got 2 views, but concurrent viewers. I see. That's not live views. That's not total views. Because if I go on, let me actually go on YouTube and see what I'm at. That's fun. Either way, it's fine. How do I even get in here? Live for an hour 40. I got 2 views. And then nothing else. That's fine. That is completely fine. Am I actually having that bad on the internet? Man, this is unwatchable. Well, whatever. I'll just end it here for today, and I'll just pretend like I'm live.